All right, so let's consider this following problem, right? Consider the following circuit. At t equals 0, the switch S right here is thrown. Find the power that flows through resistance at t equals 0 and t equals 4 seconds. At what time is the power half of what the power would be at t equals 50? All right, so in order to do this, we have to basically do Kirchhoff's law. Let's complete the circuit there, and this is Kirchhoff's law. So I start here, I go up this way. I'm going up against, so I'm going to choose my I to be this direction. All right, so go across this thing. Now I'm going across this thing in from positive to negative, so in fact I would pick up a minus 12. Okay, going across this way it would be a minus L di dt, and then going along this way would be a minus R times I equals back to the same point 0. All right, so once we have this, we can go ahead and basically compute out what this thing needs to look like. So in order to do this, what I'm going to write is I'm going to write basically, I'm going to write Z. Well, let's first divide by L first, L first, L first. Okay. And now, so let's write down the equation again. So it's going to be equal to, I'll write this minus V over L minus di dt. Minus now R over L times I. And now I'm going to define, let's see, we'll define like this. Z is equal to, so the trick is I have to absorb this thing into this I here, right? So in order to do that, let's write this thing out a little more clearly. Okay, so this is going to be equal to minus di dt minus, now let's write this thing out very carefully. I'm going to write this as R over L times I, and now bring this in, plus V over R equals 0. All right, so now I'm going to absorb this thing into I, so I'm going to define Z is equal to I plus V over R. And once I have that, okay, dz is equal to dt is equal to di dt. All right, okay, so let's go ahead and do this thing. So what I have is going to be equal to dz dt minus R over L times Z. All right, so I can go ahead and basically do a guess and check on this one. So there's only one guess you ever need to know in elementary physics, and it's this following guess: Z is equal to some amplitude exponent alpha times t. All right, so let's just plug into that one. So that's my guess. Now my check. Plug it in. It's equal to, so all is equal to 0. So 0 is equal to minus d by dt a exponent alpha t minus R over L a exponent alpha t. All right, so let's keep going. Okay, so this d by dt will bring out factor alpha here, so this is minus alpha a exponent alpha t minus R over L a exponent alpha t. And then lo and behold, because there's 0 on this side, this will kill this, that will kill that, right? And so you're left with alpha is equal to minus R over L. Okay? All right, so that's the first thing. Okay, now the other thing you have to know, basically, from looking at this plot, right, is that at t equals 0, there is no current that flows through. So I is equal to 0 at t equals 0. All right. Okay, so once you have this, okay, let's basically plug this back in. So Z is equal to alpha exponent, let's get this thing right, exponent minus r over L times t. That is equal to what? Well, I defined z somewhere. That's my z, right? So this can be equal to I plus v over r. Okay? Okay, so at t equals 0 here, right? That means that basically I equals 0, right? As defined basically up here, right? And so what that means, I can basically find out what alpha is going to be. So at t equals 0, I said this is going to be equal to 0, so this goes to 1. This is going to be t equals 0 is going to be equal to 0. And so I get basically what a is going to be. A is equal to v over r, right? So now we're done, okay? Z is equal to v over r. Let's see, so this is going to be exponent minus r over L times t. All right, okay, so that's quite nice. And now this is actually equal to I plus v over r. So basically I is equal to v over r exponent minus r over L times t minus 1, right? It's a little bit different than it was previously, right? You might, if you did previously, you might notice the sign flip relative to before, and that is because basically we put the batteries in backwards, so this thing comes to minus 12. It'll work out perfect at the end. All right, so once we have this, we can go ahead and figure out everything else. So now this is my current. Okay, let's plug in numbers here. So this is I is equal to, the voltage was 12, the resistance was, what did I choose resistance? Was 12 again, that's great. Exponent minus, the resistor is 12, the inductor was a 3 times t minus 1. So that's just going to be exponent to the minus 4t minus 1. Right, so that's my current right there. Okay, all right, so let's go ahead and do the rest of it. All right, so the first thing is I find the power that flows through the resistor at t equals 0. Okay, so now I'm going to copy down what I is going to be first on this side. So I is equal to, let's get this right, I'm going to convert this to something, well, I'll just write like this, exponent minus 4t minus 1, all right? You can check this as t goes to infinity, I goes to minus 1, and all that means is the current actually flows backwards, right? Which is right? Because as t goes to infinity, this thing doesn't do anything, and so this is a battery connected resistor, which will flow the right direction. All right, so let's basically do this at t equals 0. So the power in the resistor is equal to, there's several different ways to write this. So v squared over r, or v times I, or basically I squared times r. Now for these three different ways, the simplest one to use is this one, so we'll go ahead and use that one. So the power of the resistor is equal to r, which is, I'll write it out first, I squared times r, which is this thing up here, exponent minus 4t minus 1 squared times r, which was, I chose to be 12 ohms, right? So that's going to be equal to 12. So if you do this, basically at this is just something, right? So we'll write this as 12, and the rest of it is going to be something simple. I'm going to write it as 1 minus exponent minus 4t entire thing squared, right? So I pulled out a minus 1 out here, but minus 1 squared is just 1, so that works out fine. Okay, so this is a little straightforward. So let's set at t equals 0. At t equals 0, what is that? This is 0. This is 0. Exponent of 0 is 1. 1 minus 1 is 0. So in fact, power of the resistor at t equals 0 equals 0. That's the first thing. Okay. Second thing. Okay. Find the power at t equals 4 seconds, right? So the power of the resistor at t equals 4, well, that's just going to be 12 times 1 minus exponent to minus 16, right? So 4 times 4 is 16, entire thing squared. I'll let you figure out what that is going to be. So that's basically some answer right there, right? And now the last thing is I need to find power, what power would be at t equals infinity. So in order to do that, right, what I'm going to do is I'm going to basically set this thing equal to infinity first, all right? So let's set this thing equal to infinity. So the power of the resistor at t equals infinity is equal to, well, when t equals infinity, this thing is exponent of minus infinity. That's 0. So that's going to be basically 12 times 1 squared is 12 watts. And basically what we want to find is basically when is the power half of that. Okay, well, P is equal to, or the resistor is equal to 1/2 the power of the resistor at t equals infinity. What is that equal to? Well, that's going to be equal to 6 watts, which is equal to this thing, 12, 1 minus exponent minus 4t, entire thing squared. All right, so let's go ahead and figure this out. So this is going to be 0.5 is equal to 1 minus exponent minus 4t, entire thing squared. Okay, you can take the root of this thing. So if you do that, that's roughly square root of 0.5 is equal to 1 minus exponent minus 4t. Okay, root of this thing is about 0.07, I believe. 0.707, okay, is equal to 1 minus exponent minus 4t, right? And so what you end up getting is you get something pretty simple now. Switch this thing out. Exponent minus 4t is equal to 1 minus 0.707, right? So this is, I think this is 0.293, I believe, right? Is exponent minus 4t, right? And so we can figure this out. This is the minus 4t is the natural log, or 0.293 divided by 4, right? And that's your answer, okay? Minus logarithm 0.293 over 4. This number will in fact be positive, and the reason why is that logarithm of a number which is less than 1 is actually negative. All right. Okay.